Hello there. Today we're going to try to work a question on integration, which is coming from this book for the advanced level HSC high school certificate. And we can see here on page, let's see here. Okay. 203, all right. First question coming from the CIE, the June 2016 paper. And this is question number 2. The variant is 970931. Okay. So the question is, find the exact value of the integral with limits going from 0 to half x e to the minus 2x dx. So we're going to solve this by integration by parts. Integral of v du is equal to uv minus integral of v du. Okay, so how are we going to do this? So let's put the book away and get down to it. Right, so we can use the acronym LATE. Natural logarithms, algebraic, trigonometry, exponential. I've got algebraic here, which is this one, and I've got exponential, which is the last one. So we're going to take algebraic first. Therefore, we can say let u is equal to x, and therefore du is equal to 1. Similarly, we're going to say e to the, for the exponential, so that's now dv is equal to this one, e to the minus 2x. So we integrate this back, we should be able to get v. If you integrate this, it's going to remain as e to the minus 2x divided by minus 2, which is minus half. You differentiate the power and you divide by the new power. So we're going to apply this uv. Alright, this is uv. So x times all of that. So that means then I've got this is equal to x times this, which is minus half times x e to the minus 2x. Then v du. So uv minus integral of v du. So v is minus half. We're going to minus, in brackets, I've got minus half e to the minus 2x times du, which is 1. Okay, and there we go. So this is, okay, right. So what we're going to do, and this is in terms of x, all right. So now I've got minus half x e to the minus 2x minus integral of that is going to become plus the minus half is a constant, it can come outside, and I simply have integral of e to the minus 2x dx. So minus half x e to the minus x minus 2x plus half. If you integrate this alone, you should be able to get divided by minus 2, okay, which is then minus half, okay, and then e to the minus 2x. Right, so from here we can apply the limits, but before we apply the limits we're going to have to simplify this further. I've got half here and then 0. So I've got negative half x e to the minus 2x minus a quarter, alright, e to the minus 2x. Good, so now from here, again, let's apply the limits. So what we're saying is that this is half, so I'm going to put half here, minus half times half, okay, e to the minus 2 times half, okay, minus half, minus a quarter, e to the minus 2 times half, that's our upper limit. Take that and minus the lower limit. So if I put 0 in here, I'm going to get 0. I've got a minus, I put a minus, and then 1 quarter e to the power of 2 times 0 is 0. So now, this is looking very interesting. I've got negative a quarter. Let me see if this is in the camera. Just 1 second. Alright, so far so good. So e to the minus 1, because minus 2 times half is minus 1, minus a quarter times e to the minus 1. So this is e to the minus 1. Okay, right, and that's good. So I've got then minus becomes plus 1/4 times 1, because e to the power 0 is 1. So basically what I'm saying is I've got negative a half, because negative 1/4 is negative half, e to the minus 1, okay, plus a quarter. So what I have is a quarter minus half e to the negative 1. I just want to check if this is still in the camera. Super. Now from here I've got then 1/4 minus, I could say 1 over 2e. We use the laws of logarithms there. You can leave it as such if you want, but if you don't want to do so, you can probably put a quarter outside. You're going to have to make the LCM the same, all right? So, but that's okay. We can leave it as such. Okay, so here's the exact value of this integral. Well, I hope it helps. Take care.